Hello friends, this lecture deals with the second most important alicyclic hydrocarbon. This alicyclic hydrocarbon possesses one or more double bond in their structures, and that's why it is called as a cycloalkene. In this lecture, we will discuss the methods of formation of cycloalkene and the chemical properties or a chemical reaction shown by a cycloalkene. The examples of a cycloalkene are, I will write here, this is first example, this is a second example. In this way, we can write a number of examples in which there is a presence of one or more double bond. In all these four examples, there is a presence of one double bond. I will write another two examples in which there is a presence of more than one double bond. According to the IUPAC nomenclature, in case of cycloalkene, a prefix cyclo is used and it is followed by a name of a parent alkene. Therefore, the name of these compounds will be like this. It is having 3 carbon, that's why a parent alkene is propene and the prefix is a cyclo. Therefore, it is cyclopropene. The second example, it has name cyclobutene. Here, it is a cyclohexene. And fourth example, it is a cyclopentene. Depending upon the number of carbon atom, the parent alkene is chosen and cyclo prefix is added. That's why we get cyclopropene, cyclobutene, cyclohexene, and cyclopentene. In all these examples, there is a presence of only one double bond. Now, in the fifth example and sixth example, there are two double bonds. In this case, we have to give a number to the carbon atoms and then we will write the name for these compounds. In fifth example, I will give a numbering from this carbon. It is first, second, third, fourth, fifth. Now, the name of this compound will be, first of all, we will write cyclo, then number of carbon atoms, they are 5, therefore I will write a penta. Then look at the numbering. At the first carbon there is a double bond and at the third carbon there is a double bond. There are two double bonds, that's why I will write here 1, 3 dine. The name will be cyclopenta 1,3-dine. In case of last example, once again we will give a number 1, 2, 3, 4 and 5. In this case, the name will be cyclohexane 1,4-dine. In this way, we can name the different cycloalkene depending upon the number of carbon atoms present in their structures. So the cycloalkene possesses one or more double bond in their structures. Now, Let's begin with the methods of formation of cycloalkenes. Generally, the cycloalkenes they are prepared from a cyclic compound, and this cyclic compound is nothing but a cycloalkane. Therefore, different methods that we are going to see, they are started from a cycloalkane, and one similar strategy is used in all methods of formation, in which a cycloalkane is taken and it is having a, a group which is eliminated. I will write here X along with the hydrogen from the neighboring carbon atom, and depending upon the reaction condition, these two groups, that is X and H, they are eliminated as a HX, and there is a formation of double bond between these two carbon, and finally we get a cycloalkene. This is the similar strategy which is used in all methods of formation. Now, X, it may be a OH, it may be a Br, that is halogen, or it may be a triethylamine and OH group, that is quaternary salt. Here nitrogen possesses positive charge, oxygen has negative charge. If I replace X by OH, then it is a cycloalkanol. When there is a presence of Br in place of X, then it is a cyclo, that is a bromocycloalkanes. And if X belongs to this quaternary salt, then it is a Hofmann elimination reaction. We will see in a detail. Therefore, first method is Hofmann elimination reaction. I will write here a cycloalkane, because we know that all the methods started from the cycloalkane, and at the position of X I will put here nitrogen, here CH3. Nitrogen is attached with 3 CH3, and the valency of nitrogen is 4 in this case. That's why we have to write a positive charge, and here I will write OH negative. This is the quaternary salt of cycloalkane, and when it is heated, what will happen? It will loses this quaternary salt along with the hydrogen which is present at the neighboring carbon. This hydrogen is eliminated as a H plus, and this hydrogen and OH, they combine together to form water, and after heating we get this type of cycloalkene, plus remaining will be the triethylamine CH3 thrice N. Name of the compound is cyclohexene. Here a trimethylamine. Instead of cyclohexane, I will take a cyclopropane. This is cyclopropane. It is attached with a nitrogen. Nitrogen is having a 3 methyl group. Here OH minus and nitrogen possesses a positive charge. Similar condition, heating. When it is heated, what will loses here? Water molecule, and from this carbon, hydrogen is eliminated as H plus, which releases the electron which are shifted here, and we get a cyclopropene plus a trimethylamine. The second method is a dehydrohalogenation. Now, look at the meaning of dehydrohalogenation. Here, D means remove, and hydrohalogenation, that is hydrohalogen. It is nothing but the HX. X may be the halogen. Therefore, there is a removal of HX from the cyclic compound, that is cycloalkane. Therefore, on the reactant side, we have to write cycloalkane first, and on that cycloalkane there is a presence of halogen. I will put here a Br, and it is treated with alcoholic KOH. What is happening? There is a dehydrohalogenation, and dehydrohalogenation involves the removal of HX and hydrogen. It is came from neighboring carbon atoms. So this hydrogen shifted the electron here, and it is eliminated as a H, and this H combines with Br. Therefore, there is a removal of HBr with the formation of a cycloalkene. Different example, I will take here a 5-membered ring. We'll write a 5-membered ring. On one carbon, there is a presence of Br, alcoholic KOH. Heating is there, and it will eliminate HBr, and we get a cyclopentene. The last method for preparation, it is started from cycloalkanol. And cycloalkanol on dehydration in presence of concentrated H2SO4 eliminates water molecule to form cycloalkenes. Example is cyclohexanol. When it is heated in presence of concentrated H2SO4, here the function of H2SO4 to remove water molecule, because it is a dehydrating agent. From this reactant, water is eliminated. Hydrogen from this carbon and this OH, they are eliminated with the formation of cyclohexene. In this way, all the reaction involve similar strategy in which there is either elimination of Br, OH, or quaternary salt. Now we will turn towards the chemical properties or chemical reaction of cycloalkenes. Cycloalkene shows a chemical reaction which are similar with the alkene because it undergoes addition reaction rather than substitution reaction. Addition of hydrogen, addition of halogen, or addition of hydrogen halide take place across the double bond to form corresponding adduct. In addition to that, it also shows allylic halogenation in presence of N-bromosuccinamide. Therefore, there are four chemical properties that we are going to study, out of which first is addition of hydrogen. That is, we call it as a hydrogenation. The first chemical property, that is hydrogenation, in which addition of hydrogen takes place. An example, we will take a cyclohexene. Simple example here. I will write a double bond plus H2. Catalyst is there, nickel, platinum, palladium. And in presence of catalyst, what happens? This H2 molecule, I will write it is H single bond H, out of which one hydrogen is going to add at this carbon and one hydrogen going to add at this carbon. That is addition across the double bond and with the formation of a cycloalkane. That is here a cyclohexane. In this way, hydrogenation of cycloalkane takes place. Second chemical property is hydrohalogenation. In hydrohalogenation, there is an addition of HX across the double bond, a corresponding halocycloalkanes. We will take the example of cyclohexene plus HX. Here hydrogen is Br, that is HBr, and after addition what will happen? Look at here, this hydrogen add at this carbon, whereas Br going to add with this carbon, and we will get here hydrogen and here Br. Therefore, corresponding halocycloalkanes are obtained. Here name is bromocyclohexane. Third chemical property is halogenation. In halogenation, there is an addition of halogen across double bond, and the example is, once again I will write a cyclohexane plus here I will write a Br2, that is bromine, and there is the addition of bromine across double bond, one Br attached here, one Br attached at this carbon, so that we will get this type of compound in which there is two bromine atoms, that is dibromocyclohexane we get. It is a simple reaction in which only addition occurs across a double bond. And last chemical property is allylic halogenation. It is quite different from all other addition reaction. Let's take the example of, once again, a cyclohexene. Now, in this cyclohexene, this is the carbon-carbon double bond, and next to this, these carbons, either this carbon or this carbon, these two carbons, they are called as allylic carbons. So this is the allylic position in cyclohexene. Here we are going to see a allylic halogenation. It means that there is a addition of halogen at the allylic position. So the halogen is going to add at this position, and it is a substitution reaction. One of the hydrogen is replaced by halogen. And in this reaction, what happens when it is treated with a Br2 in presence of N-bromosuccinamide and light, we get this type of product in which a double bond remains same, and this Br2, which is going to add this allylic carbon, and we get bromocyclohexene. So out of the four chemical properties, one property involves only a substitution reaction in which double bond remains same, and all other three chemical reactions or three chemical properties involve addition reaction in which double bond is reduced to a single bond with the addition of corresponding atoms or corresponding groups across the double bond. In this way, we have studied methods of formation as well as chemical properties of cycloalkenes. Let's summarize this topic. In this lecture, we have learned the meaning of cycloalkene, its nomenclature briefly. Along with this, we have learned methods of formation starting from Hofmann elimination reaction, dehydrohalogenation and dehydration. All the methods they are involved a cyclic compound as a starting material, and here I have written all the reactions. We get a Hofmann elimination reaction in which trimethylamine is eliminated along with the water to form corresponding cycloalkene, whereas in dehydrohalogenation bromocycloalkane is treated with the alcoholic KOH to form cycloalkene, whereas in the dehydration, cycloalkanol undergo dehydration in presence of H2SO4 and heat to form cycloalkene. The chemical properties we have seen hydrogenation, then hydrohalogenation, halogenation, and allylic halogenation. Out of the four chemical properties, three shows addition reaction, whereas one shows a substitution reaction. If I take the example of cyclohexene, then upon hydrogenation, it gives cyclohexane. On hydrohalogenation, it gives bromocyclohexane. On bromination, it gives a dibromo compound. These are the addition reaction. Whereas, if the halogenation occurs in presence of N-bromosuccinamide, that is NBS, there is a substitution reaction at the allylic carbon and it gives allylic halogenation, that is bromocyclohexene we are getting. This is all about the cycloalkenes and its methods of formation and chemical properties. Finally, we will complete this lecture. Thank you. Thank you very much.